Okay, so we got a question right here. When the electric field between the plates is switched off, the electrons move in a circular path of radius 39 centimeter. I can see from the circular path that it's maybe talking about the centripetal force, the formulas of centripetal force, right? Because it's going in circular path, right? The accepted value for the charge per unit mass of an electron is basically 1.8 times 10 raised to power 11 coulombs per kg. Reduce whether the charge per unit mass of an electron calculated using data from this experiment is consistent with the accepted value. Okay, P is equals to 5.5 times 10 raised to power minus 4. Okay, so as I mentioned before, as it was going in a circular path, I can basically say, and they have been given the radius, right? They have given us the radius. So I can use, this is the first method, right? So basically you can use the formula, basically centripetal force, which is Fc is equal to mv square by r, right? And then as I can see, it is in a magnetic field, right? So I'm gonna use the magnetic field formula as well, right? Which is F is equals to BQV, right? Because they given me the magnetic flux density, right? Which is 5.5 times 10 raised to power minus 4. So I have to use this somehow to find out my value, right? So once I equate them both, I will get the formula, I will get the equation like this: BQV is equals to mv square by r. I know v square is basically v times v, right? So one of the v is gonna be cancelled from this v. So I have BQ is equals to mv by r, right? Now I need charge per mass, right? Charge per unit mass. Charge per unit mass is basically coulombs per area, right? So I need coulombs per mass. Charge per mass basically means coulombs per mass, my bad. So you need coulombs per mass, so it's Q by M, right? So Q by M is equals to V by BR, right? And then we know that we have calculated the velocity before, which was 2.8 times 10 raised to power 7, right? And then you have B, which is 5.5, right, times 10 raised to power minus 4. And then you have the value as well for R, which is 39 centimeter. Make sure to convert it into meter, because the SI unit for radius is basically, or any length is basically meter, right? So once you calculate this answer, you get this as 1.3 times 10 raised to power 11 coulombs per kg, right? So I can basically say that it is not consistent. Why? Because it is less than the accepted value, right? Accepted value is basically 1.8, right? So let me write it. Not consistent as 1.8, right, times to power 11 is greater than basically 1.3 times 10 to the power 11 coulombs per charge. You can write also the unit as well. While explaining it, I wrote an example sentence, so you can write it in your own words, right? So this is your final answer for the first method.